And then after the heist, this is Protagonist's first inversion through a turnstile.
You'll need your own air. Regular air won't pass through the membranes of inverted lungs. Don't come into contact with your forward.
So why doesn't regular air work with inverted lungs? That seems weird to me.
I don't know. The best guess that I had was that if we're going for this theory of if in the inverted world we're swapped with all the antiparticles, then it's possible that we now have negatively charged, or I guess we have antiprotons for oxygen, and then we have positrons on the outside. So now the electronic shapes, I guess the bondings don't work anymore because when hemoglobin or the lung barrier is expecting a negatively charged oxygen to go through, and then encounters a positive thing, it's like, what is this? I'm not letting you through, I guess.
Yeah, the only issue I have with that is if it's true that the inverted matter is like antimatter, then it would just get annihilated in the atmosphere of Earth.
Yeah.
Because, right, antimatter and matter, when they collide, there's an annihilation event. But as soon as he hits regular air, he doesn't explode.
Right.
In fact, that explosion would be like really, really large because you'd have a conversion of his body mass to energy, which I think would like blow a hole in the Earth.
Well, it would at the very least be gamma ray radiation, and so all his other organs would get messed up. It would happen very quickly, I think. I think it would happen pretty quickly.
I don't have an intuition about matter antimatter explosion conversion rates when they come in contact.
Well, I guess so when we touch things, that's the electric force, right? You touch electrons to electrons and they repel, and then you can't just smush your finger through itself, right? But that's because they're negatively charged, so they repel each other. And so if we had electrons with positrons around, they're now positively charged. So as long as they're close enough, they can attract and then annihilate. You get an electron, positron come in, and then two photons that pop out.
Sounds like it would happen extremely fast.
I'm not a high energy physicist.
So I don't think it cannot be converting to antimatter in the turnstile, because I think we're talking about annihilation. So it has to be reverse entropy, but while staying regular matter.
I guess.
Has to be.
I don't think so because of what she says next.
Self. It's the whole point of these barriers and protective suits. We don't have suits. Protective point of the forward self.
Okay, I'm gonna get this. Here we go.
Lungs don't come into contact with your forward self. It's the whole point of these barriers and protective suits.
We don't have time.
Well,
so she says, don't come in contact with your forward self.
Let it play like 2 seconds more.
if your particles come into contact,
What?
annihilation. When you
Annihilation would happen.
I think that's matter antimatter stuff.
But it's not like with an antimatter explosion or conversion to gamma rays that it's like, oh, you're not my inverted brother,
That's right.
therefore I'm just going to pass right on through. No, it's like any matter antimatter will be like
Any correctly paired. So any positron and electron, or any proton and antiproton. I get that goes backwards, but it's not like if we pair produced an electron and positron. If this positron encounters a different electron, it's like, no, you didn't come. You weren't created with me. Like, I'm not gonna. If that was true, we would see lots of antimatter around the world right now.
That's right.
So I don't know what this is.
Somehow it's like his atoms interacting with his inverted atoms does something real bad. But if his inverted atoms interact with, a bird or a cat or the air, like not a big deal.
Or like the floor he's walking on right now.
That's right. It's not a big deal. It's weird, but I don't have an explanation.
I don't have an explanation for it.
You exit the airlock, take a moment to orient yourself. Things will feel strange. When you run,
Reasonable.
the wind will be at your back.
When you run, the wind will be at your back.
Okay.
That's just some sort of statement about time is inverted. So when you're running forward, inverted forward, the wind is going to be at your back. Whereas if you were running normally, forward in time, the wind would be in your face.
I mean, but I've ran with like a strong wind behind me. Like, right? Have you ever like longboarded or like ride a bicycle with like a strong wind behind, or sailing? That is sailing, right? The wind pushes you forward.
So what you should have said is your airspeed will be inverted because it's all relative to the air. So like if you say there's no wind, and I run forward in time,
okay, then
the wind will be in my face.
Yeah, I'm down with that.
But if I'm inverted and I run forward, the wind will be at my back.
Yeah, okay, yeah, I guess that's what she's saying.
Yeah, and then you have to adjust it for airspeed. If there's a wind, you have to do the Galilean velocity transformation, all opposite.
She's doing these if you're running inside like a sports arena where there's no wind. Okay.
Yeah,
I'm aboard.
Yeah.
Gravity will feel normal, but if you're reversed for
so gravity being normal, even if it's reversed, so that means stuff is still falling down towards the center of the Earth. It's not falling up. You'd think it would fall up. But it kind of falls up, like when he caught the bullet, the inverted bullet, it fell upward.
Sure.
But then most things in the most inverted things fall down.
Yeah, because otherwise in the next scene where they're doing like a car chase, all the cars should just be leaving the planet.
Leaving the planet. So somehow gravity works. It's always attractive, either inverted or not inverted. It's always two masses always attract each other.
I'm okay with that, especially because there's no anti-mass. The gravity is attractive from mass particles. They pull each other, but there's no repel particle for mass.
Right. For some reason, that's how nature works. So that still holds when you're going backwards in time. I'm okay with that.
I'm okay with that.
The world around you. You encounter fire, ice will form on your clothes.
So when you encounter fire, ice will form on inverted clothing.
Okay.
I guess that makes sense.
So I think that's a statement of the arrow of time. That's a statement of the entropy is reversed. So when you have like a wood block and then you set it on fire, it's going from the low entropy state of wood to the high entropy state of burnt atoms flying around in the air. Right. Yep. So if you reverse that, now if you had a fire, it would assemble itself into wood. And so what she's saying here is instead of things getting hot, they get cold.
Mm-hmm. And so what is hot? Hot means when you go forward in time, you do a chemical reaction. Energy is released from the chemical reaction by whatever's happening
into kinetic energy, which makes it hot. Right.
Yeah. And then an endothermic reaction going forward in time is one where the reaction pulls in energy from the outside and does the chemical reaction, and the environment gets colder. So if we invert time,
like ice packs.
Yeah, like ice packs. Yeah,
okay,
exactly.
Okay.
So if we invert time, endothermic reactions become exothermic, and exothermic reactions become endothermic.
Yeah, that's tight.
Okay, sounds good.
Yeah.
Okay.
The transfer of heat is reversed.
Can I drive a car? Cowboy shit.
I can't vouch for the handling. Friction and wind resistance are reversed. You may experience distortions.
So cars would be really weird. I don't know if what you're like driving forward and backward through what? I can't even comprehend it.
I don't get it.
You like turn left and so you go right because you're going. I don't know if I understand it. Somehow he drives forward.
But I think people have done this. Like I saw a YouTube guy, he put on like inverted mirrors or maybe this way mirrors, and then he's like, I'm going to learn to have a he had a bicycle where he put some mechanical linkages so that when you turn to the right, it would turn to the left. That's something slightly different. What I was thinking about was this other experiment with cats. And so they strapped the scientists, I don't know what type of scientists, they strapped these mirrors on these cats. And so left is right and right is left. And for like maybe a few hours, the cats are like, what the? But then they actually adapted very quickly and figured out they could walk pretty normally after they realized that everything was backwards.
Right. Isn't that weird? The brain is like, okay,
I'll work with it.
Okay, yeah. So... But he just Protagonist dives right into the car and sort of is able to drive right away. It would probably take an hour or two like the cats, I would think.
Way more. Yeah, maybe. Yeah, hard to say even more. I don't know. Inverted time. I'm not quite sure all the consequences of driving. Friction is wrong, right? I think she'll say that. I don't know if she said it yet though.
In your vision and hearing, this is normal. You are inverted. The world is not.
Birds flying backwards.
This is cool.
Inverse step, that was cool.
Yep.
Boat's going backwards, that was cool.
Mm-hmm.
So we're looking
but the sound still came from the boat. I guess maybe the sound was coming from behind him and they got sucked into the boat.
That's right. So what is there for emission of light, there's the forward light and the retarded light. And so he's hearing the retarded sound that's coming from behind him.
What do you mean the
whooshing
retarded
past him?
Light?
What's that?
What do you mean the retarded light?
That is the light so there's, for everything, the light gets emitted forward in time. Okay. There's also something that comes in from the past.
Oh, I see what you're saying.
Oh, I can't remember now.
Special relativity.
Yeah. And I think that's thrown out sometimes. I can't remember. But you're saying that the sound, instead of being emitted from the boat going into his ears and past, is actually coming from behind him into his ears and back to the boat.
I guess so.
It has to be, right? Yeah. It was a cool scene. It felt really weird.
Yeah.
Especially that step was like, whoa, that is interesting. Go ahead. Okay.
Okay, I was coughing.
Okay.
So it feels really weird because the human eye is very good at seeing the arrow of time and very good at seeing effectively the second law of thermodynamics. Like, you know what a before state is, and then like, say you have a bunch of marbles on a trampoline. Like, if they're all sitting there and not disturbed, you know that's a before thing, before the kid jumps on the trampoline and the marbles are all over the place. Right? So same thing with that puddle. Like, you know what it looks like for water to be disturbed. And so when we see it backwards, already disturbed before the thing happens, super weird.
Super weird, yeah. But
people are good at physics.
Yeah, and I think that's why it's one of the big problems with time travel is that the puddle shouldn't react before he steps. Otherwise, he has to, like, the lineup of events where the puddle is reacting right where his step is happening. The mathematics, the probabilities of that happening are so low that I don't think it can be possible.
I mean, I'll caveat what you said about time travel. It's specifically this type of negative time. It's because if you jumped back into 1984 and then walked forward in the time, things would be the normal, right? It's specifically this time goes backwards that looks really weird.
Yeah, really weird.